Hi everyone, this is Billy. I'm creating a series of videos to show you how you can design and create a stove and oven using metal sheets. For example, stainless steel sheets of 0.2 millimeter thick, or the titanium metal sheets of 0.15 millimeter thick, or a regular tin can metal sheet. But if you use tin can, you better spray paint it with a high temperature black paint for the stove. Cover the following topics. The first, why you need a tent stove. Then the design of your own tent stove. Then we'll talk about what tools to be used, what material you need and where to buy it. Then we'll start creating the different type of tent stove, starting with the simplest one, followed with the stove with an oven, and stove with two ovens. First, why you need to build a tent stove. Tent stoves are used inside a tent. It allows you to keep warm. You can cook food instead of a regular stove that the exhaust air, the smoke all just come outside. The tent stove will funnel that through a chimney, so you can feed your chimney to let the air out outside of the tent, and you won't be suffocated with CO, carbon monoxide. Tent stove also has its own drawbacks. The most important one is it's not too efficient because you are heating the food through another piece of metal that needs to be heated up first. So there's a transfer of heat energy that's not that efficient. However, it allows you to cook with utensils that you don't need to clean up so well. Otherwise, if you put it directly on the fire, your utensils will be covered in a layer of black tar that is hard to remove. I've been designing my own tent stove. Let me show you what I got. The first design is using stainless steel to bend the stainless steel in a vertical U shape. So you see there, the vertical U shape is a 0.2 millimeter stainless steel bent together, and is formed by also the cover and the bottom, which keep this U shape. Inside that stove, we have another U-shaped stainless steel bench upside down. So that one is for the oven. So this design is very easy to make, save your material, and you can just roll up all those bended stainless steel into a roll, put it inside a Coke can, and then carry it away. This is just a conceptual design at the moment. If I got time, I will create a proof of concept version so I can share with you in my other videos. The second design is a more conventional one. I will use individual metal sheets modules and then hook them up together using hinges. They are basically tracks and slits that can be slid in and locked down one by one. So you got the oven at the top, there's the combustion room in the middle, and then another oven at the bottom. So the red arrow shows the direction of the hot air flow, and the small arrow shows the heat transfer that will heat up the oven and the bottom oven. The beauty of this design is that the top oven is also the buffer. So the hot air generated out of the combustion chamber rises up at the back of the top oven and then pass through the crack between the top surface of the top oven and the top of the stove. That way it can heat up the top oven. So the top oven will sustain the temperature of 350 degrees for a long time. Whereas for the bottom oven, you only get one way pass down of heat energy from the combustion chamber downwards to the bottom oven, and that heat transfer is not very efficient. So the temperature you are going to get max is 150 degrees Celsius. It will be good for cooking or heating up food that don't need a high temperature. If you find the top oven's temperature too high, you can always open the oven door or the wind gate to let the hot air out a bit, so you can reduce the temperature down to 200 degrees Celsius. In my video series, I'm going to show you how to build from the simplest stove with only 6 pieces, like the one shown on the screen, that are connected together through hinges and slits and tracks, and it will be very easy to make. You just need to bend some metal sheets and hook them up. Once we finish that, we can add more details to the first stove by adding the wind gauge, the circular wind gauge, as well as adding a window so we can see through the oven. We'll also add a piece of U-shaped metal to the top of the stove to form the oven, the top oven, which in itself is also a buffer for the stove. The third design is to add the legs to the stove and oven, and the legs itself is also created using the metal sheets. And by combining the metal sheets and putting a bottom, the bottom oven is created. Next, let's look at the layout of the metal sheets. So this is the oil can that you can find on the street. Measure 240 times 240 times 350 millimeter. You can use that and cut it down into 6 pieces and use those metal sheets to create your stove and oven. Next, we need to create a model for your stove. So you have this model of a general stove with the chimney at the back without buffer, with a small wind gauge in front. It's measured in the height value of 205. I put a name of H there. And then for the width, W is 175. For the length, L is 305. So this is just my value. You can substitute your own value to design your own stove. This is how you can lay out your material for cutting. So we need 2 pieces for the top and the bottom. The length is L plus 40 millimeter. Width is W plus 40 millimeter. The additional 40 millimeter divided into 20 millimeter on each side will be used to bend into a hinge. So it will be divided into 2 parts. The first part is the outer part, which is 7.5 millimeter, is bended 180 degree. And then there's another part, 12.5 millimeter, which is bended 90 degree to form a hinge. The second type of layout is for the 2 sides. So L plus 40 is the length, H plus 20 is the height. For the length, it's the same as the previous layout. It's for a double bend at the front and the back. For the height, we need extra 20 millimeter more, 10 millimeter at the top, 10 millimeter at the bottom. It will be a simple one-way fold, 180 degree. The third layout is the front and the back of the stove. So it's W plus 20 millimeter and H plus 20 millimeter. It's a simple one-way fold at all 4 sides with an edge of 10 millimeter. Let's fold them 180 degree. Once you made all 3 types of modules or layout, you can bend your metal and slide them together to lock them in. Let me show you how. So this is the track and slit. You just push it in and then it will be locked down. Okay, then we put in the back of the stove using another joint. So this is a one-way fold, slide into the 2-way fold there, Just push it in and it will be locked down. Once all 6 pieces are locked down like that, you have a good stove. Next, let's talk about the tools. We are going to use a lot of measurement tools. These rulers, they are steel rulers, so it will be easier to draw lines using a sharp edge or a pen. And you have a protractor to measure the angle when you need to divide the wind gauge into 3 pieces within the circle. Then we have the compass to draw the circle for the wind gauge and pinpoint the center of the circle for drilling and securing the wind gauge. And you have the pen and pencil and also the puncher to draw lines. I prefer to use the puncher because I can draw very narrow and sharp lines, easy for cutting the pieces and bending. You have the sheet metal cutter or scissor, and you can cut the sheet metal. Next, we have the clamps, 2 types of clamps to help you fold your metal and bend your metal and to cut the wires. Or if you want to make a lot of stoves or want to make the stove faster, you can create this sheet metal bending machine. I will create another video to show you how to create it. It's basically made out of 3mm aluminum metal and also the wood and hinges. Then we have the rivet and the rivet gun. So I'm using a 3.2mm size rivet. Also need a drill and a drill bit. We use the 8mm one for installing the temperature meter and the 4mm one for fitting in the rivet. You also need a hammer to bend the sheet metal or flatten them out to remove the folds. Then you also need a nail so you can mark the place where you need to drill, otherwise the drill bit will split and you will miss the drill. Finally, you need some wood blocks. The square one, the cube, is for you to drill on. The rectangular one is for you to bend your metal. You can put your sheet metal on top, align it with the edge of the wood block, and then hammer it and bend it to bend the metal. So what kind of material we can use to build our stove and oven? The first choice is these tin cans. They are used to store food oil. So you can pick them up from the back of the restaurant or the recycling place. Then by just cutting out the 6 pieces that made up this box and salvage those metal sheets, you can start using it for making your stove. The other choice is to buy these stainless steel sheet metal rolls. So it comes into different thickness. I will use 0.2mm for the side wall of the stove and 0.3mm for the top of the stove. And they also come into different measurements. 300mm times 1 meter costs you around $30. And the same 0.2mm times 600mm and 1 meter long costs you $30. So it seems the latter one is less expensive to buy. If you want to reduce the weight of your stove and get it down by half, you can try to use titanium sheet metal. They are around 6 times more expensive than the stainless steel ones. So here are some of the reference I got from the online shopping site. That's the end of my first video, the first lesson. In the next lesson, we'll talk about how to start cutting your metals and bending it. So stay tuned. If you like my video, click like, subscribe, share with your friends. When you subscribe, please remember to click the bell as well so I can notify you of new videos. Thanks a lot for watching. This is Billy. Bye now.